Of the estimated 200 billion stars that make up the Milky Way, only one is vital to our existence. A relatively small main-sequence star that we call the Sun. The Sun, like most galaxy stars, did not form alone. A massive gravitational pull holds a large family of small and large objects around it, all formed by the parent star. The largest of these objects are known as planets. From ancient times, humans have identified 5 planets among the stars in the sky and become acquainted with neighboring worlds. Using telescopes and space observatories, we have been able to locate 2 other planets, hundreds of moons, and more than 1 million smaller objects, including comets and asteroids left over from the solar system's formation. Planets orbit the Sun on a flat surface, and the farther we go from the Sun, the smaller objects orbit in more scattered directions. The closest planets to the Sun, Mercury, Venus, Earth, and Mars, are small, rocky structures made of rock and metal. On the opposite side are Jupiter, Saturn, Uranus, and Neptune, outer planets. Giant planets whose main constituents are gas and liquid have systems full of multiple moons. Despite the vast knowledge we have learned from our neighbors in our solar system, we may never be able to comprehend the greatness of our planetary system. Large objects may be located on our solar system's outer, dark borders that have not yet been discovered. Rocky planets. The planets closest to the Sun, Mercury, Venus, Earth, and Mars, have far more rock and metal than gas. Each has a specific surface formed during volcanic activity and the passage of molten material out of the planet. Except for Mercury, these planets have significant atmospheres that have protected their surface from collisions with celestial bodies on various scales. The formation of this atmosphere is most likely the result of collisions between comets and asteroids. It was probably comets that brought large amounts of water to these planets. Of the rocky planets, only Earth and Mars have moons. The natural moons of Mars, called Phobos and Deimos, are planets trapped by Mars' gravity. Gas planets. The 4 outer worlds of the solar system, Jupiter, Saturn, Uranus, and Neptune, are swollen giants formed by the accumulation of gas masses around dense nuclei, around which a large group of large and small moons can be seen. These planets grew large enough in their youth to absorb gas from the surrounding nebula and become larger. The distance from the Sun has caused severe cold in the environment around these planets, and for this reason, many of the moons of these planets have an icy crust. Due to the gravitational tide phenomenon, some of them heat up. Some of these moons have atmospheres, and others have active volcanoes. Small objects. In the first days of the solar system's birth, dust and ice grains formed the first small objects, and it was from the accumulation of these objects that the planets formed. However, billions of tiny masses did not join the planets and remain so to this day. We see these objects today as asteroids and comets, and studying their composition provides valuable information about the early conditions of the solar system. The smallest of these objects, dust grains, are seen as meteors entering the Earth's atmosphere. But the impact of more important things on the ground can be dangerous. These rare collisions cause widespread destruction on a global scale. Like what happened 65 million years ago and led to the extinction of the dinosaurs. Solar system. The Solar System formed about 4.6 billion years ago from a nebula full of gas and dust slowly spinning around. The accumulation of gas and dust created numerous planets and small objects that all revolve around the Sun. The most important factor in determining the chemical composition of planets is their distance from the Sun at the time of formation. As objects move farther from the Sun, ice crystals, water, methane, and other gaseous molecules become more abundant. The Solar System is much larger than the planets orbiting and extends long distances beyond Neptune. On the other side of the eighth planet is a scattered plate of frozen worlds, some hundreds of kilometers wide. At much farther distances, there appears to be a spherical cloud of small icy objects called the Oort cloud. All the planets move in a stable orbit around the Sun, and these circuits are almost circular and are all located on a flat plane. The speed of the planets depends on their distance from the Sun. So, Mercury moves much faster than Neptune. Comets, extra-Neptune objects, and many asteroids have more elliptical orbits in which the distance of objects from the Sun changes dramatically. Now let's take a brief look at the distance of these 8 planets from the Sun. Be with us until the end. Mercury. The most minor planet orbits the Sun every 88 days. Venus. The planet, which is about the size of Earth, has a dense, hot, and deadly atmosphere and orbits the Sun once every 225 days. The Earth. Our house revolves around the Sun at the best distance, and this has caused liquid water to be on its surface. The Earth revolves around the Sun every 365 days. Mars. Mars is cold and has a thin atmosphere, and we speculate that Mars is the host of primitive life. The planet orbits the Sun every 687 days. Jupiter. This massive mass, which orbits the Sun about 5 times farther from Earth, is also heavier than the mass of other planets. Jupiter orbits the Sun once every 4,332 days, equivalent to 12 Earth years. Saturn. The second largest planet in the Solar System, which has wide rings around it, has the lowest density among Solar System objects. Saturn orbits the Sun once every 10,759 days, equivalent to every 30 Earth years. Uranus. Uranus is so dim that it cannot be seen with the naked eye. It takes 84 years for Uranus to orbit the Sun once. Neptune. The farthest known planet from the Sun is more than 30 times the distance from Earth to the Sun. Neptune takes more than 164 Earth years, or 60,182 days, to orbit the Sun.